This is Automotive Electronics Test 13, Monday morning, and we're going to talk about gauges. Electromagnetic gauges use heat to produce needle movement. That is not true. Electromagnetic gauges basically have two windings in them, and they actually, whenever they got power on one winding, ground on another one, and the third, power on one terminal, ground on another one, and the third one comes from the gauge. So now, I've actually got a worksheet on this, but when you're troubleshooting a gas gauge on most cars, they have simple magnetic gauges on them. Now, some of them, you've got the instrument cluster is actually a computer. It's not, the older instrument clusters like the one we did that worksheet on earlier is just a bunch of gauges with a printed circuit and all that kind of stuff. But when it's a computer, you got to treat it like it's a computer. But one way or another, what I'm always thinking about is, how does a fuel tank sending unit work? Can you tell me how a fuel tank sending unit works? Get any idea? It's got, well, you've seen them, right? They got basically a little wiper that goes up and down.
Yes,
and the resistance is different at the top than it is at the bottom.
Yeah.
Most of the time, whenever the resistance is down close to empty on these newer gauges, the resistance will be low. You need to find out what it is if you're wanting to really test it accurately. But what you can do is you need to switch the car off, and you need to unplug the gauge for the sending unit from the gas tank, and it may be hard to get to on some of them. And you turn the key on, and you see where the gauge goes. Where should it go if you got really high resistance? If the resistance of the fuel tank sending unit is high when it's full and low when it's empty, then it basically should go over past full when you unplug the sending unit, right? So you look and see if it goes past full. In other words, you unplug it, switch on the key, does it go past full? This is not complicated, because some people just get totally bumfuddled. Now, there are some, like Ford's got a little module, a little slosh module, which is an electronic board that plugs into the printed circuit on some of their cars in the 90s and whatever. And that little slosh module was there to keep the gas gauge from reacting to fuel sloshing, right? Mm-hmm. All right, because they don't really want it slipping around. All right, so they unplug this thing, and you short the two wires together. Like, if you know which two wires it is, you got to be careful which wires you're shorting there, because you don't want to short the fuel pump wire to ground and then turn the key on, because it's going to send power screaming back there. And it's either, if you're going to jump something, if you did it right, you need to do it with a fused wire. See, what I'm getting at is, you've unplugged from the sending unit. This is a sending unit as it goes into the top of the tank, right? And you're going to have 4 wires here usually. I'm just trying to make this as simple as I can, right? Okay, and in here you're going to have 4 pins. All right, so you've unplugged this connector, and now you're looking into the connector. And they may be various different shapes. I'm just doing this because it's easier to draw a square. And coming out of here, you got your wires. Looking at wire colors on your wiring schematic, you're going to determine which of these are ground and which of them is signal and which one fires the pump. Usually the pump wires will be the heavy wires. You'll have heavy wires going to your pump. Usually have like 14 gauge or 16 gauge wires going to your pump. You'll have like 20 or 22 gauge wires going to your gauge. All right. Let's say that I've determined by looking at the connector pinout in the module that this right here, these 2 wires right here, are the ones that operate the gauge. All right. When I take, and you're supposed to take it's best to take a little 2-amp fuse or something like that, and you put a little 2-amp fuse holder, hook that into your jumper wire, and jump this, with a little 2-amp fuse in it through there. The reason you do that is if you accidentally hook up to the wrong one, you turn on the key, and the fuel pump, relay shoots a bunch of voltage down here. It'll go pop. It'll pop the fuse, like if you're in the wrong wire. All right. Now that you've done that, what should the gauge do with that wire jump together?
Go to the empty.
Poof. But you switch on the key. Why do you switch the key off and on before you make your connections? Because it's going to have to correct. It won't correct. Have you ever gassed up a car with the engine running in a cold winter time or something, and you put $30, $40, $50 worth of gas in it, and then you get back in there and the stupid gauge is not all the way up to full, it's creeping up real slow? You're wanting to do this so that it will make its correction very rapidly. And you might even notice it's going to correct slowly because it doesn't want to slosh, and they're all set up that way now. Now I wanted to make sure that everybody got that. That's something that I've got a worksheet on that I passed out, and you guys need to know that. So check in your gauge. If your gauge don't work right, if the gauge doesn't work at all, let's say I unplug this and I unplug it and the gauge stays still. When I switch the key back on, I know there's a problem with the gauge. if I jumper them together and it don't move, and they say, go what? Now they make you a little resistor that you can, little box that you can test gauges with, where you can dial different resistances up and see, makes the gauge go where it wants. But you can do it this way and it works just as well. If you can calculate, like if it was 22 ohms empty and 145 ohms full, what's halfway between 22 and 145?
122 and 145.
Yeah, what's halfway between 22 and 145 ohms? Can you do the math? That's pretty cool, isn't it? Halfway between 22 and 145 is, what if you subtract 145
What I'm doing.
from 22 from 145 and cut that number in half?
That's hurting my head.
Yeah, it's 123, so it's about 60 ohms.
61.
Now you're going to add 10 to that, right?
Why you add 10 to it?
Well, because you subtracted 22. So it's going to be about 60, it's going to be about 70 ohms.
7 ohms.
Roughly. That's so. If you get a 70 ohm resistor and you hook it in, where should the gauge go? Half a tank. You get me?
Yep.
You understand what I'm saying? Okay, this is not complicated. All right. It's normal for some electromagnetic gauges to remain at the last position they saw when the ignition is turned off. That is true. When you switch them off, it may stay where it was. And I tell you something else. On these Winstars and stuff that had the front electronic control module and the rear electronic control module, that rear electronic control module is responsible for taking the fuel tank sending unit information and feeding it to the cluster. It also is responsible for operating the lights in the back and everything. It does all of that crap. Now, if for some reason the gas tank sending unit goes stupid and it stops giving you any kind of reading, well, on those vehicles, the gauge will just stay wherever the last good reading it got was. And so people run out of gas because of that. They think they got gas and they don't. Anyway, unless Ford's done a reflash on that. Reflashes are coming out all the time for stuff. The speedometer displays a speed based on an electrical signal from an output speed sensor. That is true. If I've got a speedometer that is not operating, what are we going to want to know first? If I've got a dead speedometer, to begin with, if my speedometer is reading speed, but the odometer is not recording miles, and I've typically got a bad speedometer again. If I'm recording miles, but I'm not reading speed, I got a bad speedometer again. Because if either one of those is working, I know there's a speed signal making it to the head, and that's two components that are built together. See what I'm saying? You can common sense that. I did that for years. I mean, people even on the old cable-driven speedometers, if they say my speed reads just fine, but my odometer don't change, or vice versa, or whatever, you can see that kind of stuff. But on a speedometer, what I'm going to do nowadays is I'm going to plug in my, you can plug in your scan tool, and most of them you can actually go into the instrument cluster and tell it to sweep the needles. You know what I mean? It'll actually sweep the needles back and forth, or you can pick various stuff. But I always want to also go in there and see, well, you can actually listen to what the customer says. If they say, my speedometer doesn't work, I'm going to say, does your transmission shift like it's supposed to, if it's an automatic? They're going to say, yeah, I don't have a problem with my transmission shifting. I say, well, do you have any kind of an ABS or check engine light or anything like that? No, I don't have anything like that. Well, then probably you got something wrong with your speedometer here. Because if your engine controller is getting speed information from the sensors, then you can tell if the transmission shifted like it should.
Right.
Because the speed sensor is what tells it how fast it's going, and that's when it knows to go to the next gear. If the vehicle speed sensor doesn't work, it's just going to hold first gear because it doesn't even know you're moving. Got it? Or electronic transmissions that way. All right. So
You know how like some cars throw codes with the check engine light, the malfunction indicator light.
Yeah.
They throw codes. On our way back from Michigan, we just got through Indianapolis, and the Honda started throwing. I think it was throwing codes because it flashed 3 times and stopped. And about 10 minutes later, flashed 3 times and stopped.
Yeah, you had an intermittent misfire. I mean, if it's flashing now, what year was that car? I forgot.
2000.
It's an OBD2, so it's going to be if the middle light's flashing, it's detecting a misfire. It may be one you can't even feel, because the computer's real sensitive to that.
Yeah.
But the misfire monitor is going to make it. That's the only thing that'll make that light flash. Usually, is a type. Was that type A misfire? All right. So, but yeah, that's what you had there. And if you check the code on that, you'd have probably found a PO30 something, or it may even be something like a PO300. if it's a skip that's moving from cylinder to cylinder, or it can't tell which cylinder it's skipping on, it can just tell that it's skipping, and it'll throw you a PO300, and you're saying, oh crap, you wanted to tell you it was a PO304 or, or whatever. You know.
Cylinder almost.
Yeah, and then sometimes it just jerks you around that way. Let's see. Federal and state laws prohibit changing the correct mileage on the odometer.
That is true.
Well, that's right, but what we used to do, this is kind of funny, this guy wheeled into the Ford dealership, and he had a problem with his speedometer. On his speedometer wasn't reading right, I can't remember what the deal was, but it was under warranty. Or he may have even paid us to replace the speedometer, I don't remember. But in those days, that little wheel on the speedometer that had your miles on it, if you replaced the speedometer, the one that you put back on there would have red numbers for the tenths. And that way, whoever looked at that vehicle would instantly know that the speedometer had been replaced. That was a red flag. Instead of having white, they'd have black numbers for the miles and a red number for the tenths. In other words, most of them now are a black drum with a white number.
Yeah.
Well, in those days, they were a white drum with a black number, and the tenth digit would be red. And so we had little stickers that came out of the box with a speedometer, and it said, notice this speedometer, you're supposed to put it right by the VIN sticker on the door, and it said this speedometer was changed at such and such a number of miles. Okay, so what we would do for years, rather than do that, was we would take the speedometer apart and set it so that it had the same number of miles the original one had. Well, I figured out, most of the time the little odometer drum, there was not a problem with it anyway. And so I would just pull the speedometer apart and take the drum out of the one that was on there and drop that drum in there, and they had exactly the same miles. They still had their their black tenths digit.
That's illegal to do now, though.
No, not as long as the mileage that's leaving if it's leaving the shop with the same mileage that it came in, that's right. But technically, and did you know in the shop manual it said it is illegal to send a car out of the shop with fewer miles on the odometer than it had when it came in. And then they said, but we do not release a shop manual procedure for setting the odometer to the correct mileage, because they knew if they did, people would find that and they would jack around with their odometer, see. All right, and so what I would always do, every time I did one, unless it was an electronic one and they'd set it before they sent it, we were supposed to down the car. We were supposed to park, if I had to have a speedometer, we were supposed to park that car if it was one of these electronic ones that had to be set at the plant before they sent it, and we would impound the car and keep it until the part came in. Technically is what we're supposed to do. So that way the car wouldn't have no more miles on it than what was true, see. Well, anyway, the shop foreman was trying to figure out what the right course of action was on this, And he says, I'm not, for years we all done it, but he said, I don't know, Donnie got one, and he just, the speedometer, he threw the ticket and then the speedometer, the part was coming in, boom, he popped it in there and threw it out in the yard. And the customer, as soon as he got in it, he drove around to the used car department when he saw that red tenths digit. And he knew that meant that the speedometer had been changed. So he went to the used car department. He goes, what's this red tenth digit going to do? Even though Donnie put the sticker on the door, he did everything above board. The guy says, what's this going to do to my resale value? And the guy at the used car department says, I can tell you right now, it's going to knock it 25%. 25% of what that car is worth just went out and went in the toilet when you got that speedometer replaced. So he went back into the write-up area. Hey, can we do something about this? And so, Donnie was in a bad mood that day or something. So anyway, they went in there and said, take care of this for me. And he goes, I did what I was supposed to do, and I got paid for that job. You stick it in your ear, I don't care what happens. Blah, blah, blah. So whenever somebody got their head snapped off like that, they always come to see me. Hey, can you help us with this? Can't pay you anything for it. I said, yeah, I'll help you with it. And I pulled the cluster out, got the drum from his old speedometer, which Donnie still had on the bench, popped it in there, and he was happy, and everything was fine. And then Philip came out there, the shop foreman. He goes, I'm not sure we ought to be fooling with these speedometers like this. And I says, well, Philip, it's not supposed to go out here with less miles than what it came in on it. And he says, oh, we're supposed to put that sticker on that door. I said, what if they peel the sticker off the door? Who's going to get burned then?
That's true.
You know what I'm saying? He goes, I'm talking about his speedometers. So he stormed off, and he told me to, kiss his fanny later. But the thing about it was, he could not argue with that. If the customer says, well, I don't like it, and they razor blade that sticker off there, then they're going to say, hey, they did this at the Ford place, now we get burned. See what I'm saying? But if it's got the right miles on it when it leaves, see what I'm saying? Now, that's sort of irrelevant now, because every instrument cluster you replace, including the one that I ordered, I had to put one in the 04 Silverado at the end of last semester. And not only do you have to tell them how many miles is on it and the serial number of the truck when you order it and all that kind of stuff, But when you get that cluster in your hand, it has to be reflashed before it'll even work. And so, and I had to reflash it. Now they charge like $45, $50 to reflash it at the dealership. But for $60 here, I could actually download the calibration, use my pass-through program, and reflash it here in the right there in the truck. See, so this pedometer stuff is like that. I mean, anyway, that's serious business. Anybody that, and a lot of the times they're not even supposed to sell you a speedometer if you're a customer that just walked in.
My 240's got 54 miles on it.
Yep. Well, anyway, the tachometer receives its signal from the positive side of the ignition coil. That's wrong. Actually, the tachometer nowadays, most of the time, receives its information from the data stream. You know, but in the old days, it was coming off the negative side of the coil. If you look at that 350 out there that's on a stand, it's got a little tachometer on it. The negative side of the ignition coil on that under that distributor cap where that's coming from. Let's look at number 6. Technician A says in most electronic gauges, the sending unit resistance is low. If the sending unit resistance is low, the gauge will read low. Technician B says in most bimetallic gauges, if the sending unit resistance is low, the gauge will read high. Okay, who's correct about that? Based on what I told you a while ago, if the sending unit resistance is low, which means if you short it out, it's going to read low, right? Both those guys are right. In bimetallic gauges, if the sending unit, bimetallic meaning what? A bimetallic gauge had two pieces of metal, a bimetal gauge that was married together, and they would expand at different rates. And so they had a little wire wrapped around that gauge that was like a little heater. And so the more of a ground that you'd be getting through that sending unit, the more that little piece of bimetal would move. And it had the needle hooked to it, and it would drive that needle, see. Now, the downside about that is there's a little voltage regulator that puts a sort of a gentle flashing signal out to that gauge to, you know, keep it from overheating that little heating element in that gauge. If you ever wind up losing the ground for that, and I did this one time on a Jeep 93 Grand Wagoneer. I took the instrument cluster out, and in so doing, the ground wire for the gauges was hooked under one of the screws that was holding the cluster, and I happened to have a cluster just kind of laying up in there, and I switched the key on, and they had bimetal gauges on it, and every one of those 4 gauges went all the way to the high side and burned out.
Really?
Yeah, I lost every gauge in that cluster because most of them have that ground somewhere else, but that one had it under one of the screws where you mount the cluster. And boy, did that put egg on my face. I didn't have a clue that was going to happen. But it could happen to anybody. If you're not used to working to a particular kind of car, it's like Ethan, this one guy that was in here, had this Honda car. And I had told him how important it was to center the clock spring. And he put a doggone steering rack on his Honda. And whenever he put the steering rack on the Honda, he didn't pay no mind to which way the wheels were turning. He broke the daggum $400 clock spring, and he lost his airbag and his horn when he did that. And he didn't have the money to put on a clock spring, but he didn't listen when I told him you got to have it dead center. All right, number 7. Technician A says needle movement in a 3-coil gauge as a result of the interaction of 3 electromagnets and a total field effect on a permanent magnet. Technician B says interaction of a permanent magnet and electromagnet and the total field effect causes the needle movement of the D'Arsonval gauge. Yeah, that's a C. Well, yeah, that's a C. Both of them guys are right. Let's jump on here to number 8. The fuel gauge of a digital instrument cluster is missing 2 segments of its numerical display. You know what I'm talking about. You got all those little segments that make up like an 8, and you can light or unlight parts of those segments and make any number you want to from 1 to 0 to 9.
Yeah.
All right, so if you got 2 segments missing, Technician A says the cluster has excessive ground circuit resistance. Technician B says the cluster needs to be replaced. Number 8 is, and you go ahead and replace it, you can't fix that. Technician A says, depending on the manufacturer, a new IC chip may be programmed to display the last odometer reading. Technician B says some manufacturers provide for replacement if the IC chip fails. Who is correct? C is right about that. Technician A says a tachometer is used to measure drive shaft speed. No. Technician B says the tachometer receives its signal from the plus side of the ignition coil. Why are they asking that same question again? That's D. Neither one of those guys are right. That was a dumb question anyway. They're just trying to burn it in. You know, they think you've already done it. Technician A says if all gauges are not operating, check the fuse. Technician B says if only one gauge will be affected. Only one gauge will be affected if the instrument cluster ground is open.
A.
That's A only. Yeah. 12, technician A says air core electromagnetic gauges and quartz swing needle displays are similar. Technician B says in quartz needle displays, a coil is connected to the system voltage and B coil receives a voltage proportional to the input frequency. Don't you just love those kind of questions? That's C is what that is. That's kind of, you'll find the details on those kind of gauges in your book, if you ever read your book, all right, which you will whenever you take your final exam.
When is the final?
It's going to be next week.
Next week?
I'm going to throw the finals next week, and everybody's going to be completed with their written finals before the end of that week if they do what they're supposed to. And then I'm going to show everybody in here what their grade is based on what I've got, what they've done, and what their written final is. Chances are most of the guys in here will not like the grade that they see, because most people in here have got crappy grades because there's so many worksheets they haven't done because we've been doing a lot of lab work. And that way they will be able to fix that. You see what I'm saying? And we'll be able to close up all the holes in the Swiss cheese. You know what I mean? Do you know why cheese has holes in it, by the way, Swiss cheese? You ever wonder about that?
Because there are worms getting in it.
Well, you're not all that far off. There's bacteria in there. And that bacteria eats part of that cheese and makes carbon dioxide that gets trapped in there. It makes a little carbon dioxide bubble. And that carbon dioxide can't escape, you see. And so, you know, the bacteria is gone by the time you get to your cheese. But the bacteria is what did it. It's pretty interesting. But anyway, you're going to learn something today, ain't you? All right.
Learn something today.
Yeah. Let's see. Technician A says if the speedometer is not working and the BCM or cluster module passes the self-test, the fault may be in the vehicle speed sensor circuit. Technician B says if the speedometer works but the odometer does not, the vehicle speed sensor is most likely the problem. Yeah. That's A only. Now, always remember that. You're going to look for any of this electrical stuff, and I've got two pretty serious electrical problems out there that I'm going to throw at people today. The Neon is a total no start. It's got one little bitty problem, and the scan tool won't talk, the wipers do crazy things sometimes, and the engine won't start.
Okay, it was running last, or?
It's not now because I planted a bug. Okay.
You planted a bug on the bug.
I planted a bug, yeah, on the Neon. And there's another one that, and you've done, I think you've already been through this. I think you went through it. That Grand Prix out there, the power windows don't work.
Yep, I could.
And that one there will smack you around if you're not really at the top of your game on that kind of thing. But see, the thing about it is, you're going to run into this stuff if you're anybody that's doing any kind of, if you're the guy that's getting paid good at the place where you're working, you're going to be the one they give stuff like that to. Now, if you're the guy that doesn't do anything except oil changes and changing belts and hoses and maybe putting brake pads on every now and then,
I hate doing that.
yeah, I don't mind doing this stuff, but at the same time, but if that's all they're going to give me to do, I know I'm not going to get paid very good, because just about anybody can learn to do that fairly easy. But the guy that can find out how to surgically repair something when everybody else has given up on it, he's the guy that gets paid the big bucks. Got it?
Yep.
All right. Let's see. Technician A says a ground in the circuit between the indicator light and the pressure switch could cause the oil pressure light to stay on when the engine is running.
That's true.
That is absolutely true, because all it is, you got power coming in one side of that little bulb that says oil, and then you got a wire going to the little oil pressure switch on the other side. Now, so a lot of these, now get used to this, the fact that a lot of these gauges are tied into the body computer, and the instrument cluster is a computer, and a lot of the times these gauges are actually sending a request to the computer, and the computer decides to turn the gauge on. So but one way or another, if that wire is touching ground, then you're going to have that. I had that one that you may have heard me talk about last semester. That was a Jeep Grand Cherokee, and the high beam indicator was flashing a binary code. And so I was, scratching my head about that, because there was nothing anywhere in any book that I ever saw about that, and you couldn't look at a wire schematic and figure out what was going on. And so I called the Chrysler hotline, and they said, well, that's probably an instrument cluster, which is under warranty anyway. So I put a $600 instrument cluster in it doing the same thing. And then I found out it was a $125 body computer. And when you bright the lights on that Cherokee, you're actually requesting that the body computer operate the relays to turn the lights on bright. Then the body computer communicates with the cluster and says, can you please give me a high beam indicator? You know, see what I'm saying? All that stuff used to, you just had the high beam indicator tied into one of the lights going, you know what I mean, or going all that way. But that ain't the way it is anymore. It's all electronic. And you can go into your body computer and pull it up like we were looking at the door lock thing a while ago, and it will actually show you when it's getting the switch signal. You don't necessarily have to get down there with a meter and all that. You just turn on your scan tool and go to the right place. That's how that works, but you got to be able to think it through. All right, let's see. Technician B says an open in the pressure switch could cause oil pressure light to stay on. Well, what's an open? An open is actually when it's like the wire is cut.
Yeah.
If you cut the wire, is the oil light ever going to come on? It may prove out, but it's not going to come on if you ain't got good pressure. You know? All right, number 15. And I will tell you this, on the Fords with the electronic, with the magnetic gauges on, the oil pressure switch is nothing more than a contact switch that closes when you have oil pressure. That's backwards from the one that turns on the light. It closes when you ain't got no pressure. On the Ford, it closes when you do have pressure. And what happens on that is you got a 22 ohm resistor between the oil gauge sending unit and the gauge, and that makes the gauge read in the middle all the time. It's not a true oil pressure gauge, but it actually has got a needle, but it's got a little light that'll tell you when the oil pressure is low. Whenever that thing, and the contacts in that sensor get dirty over time and get where they got a little oxidation, and they'll get where they just won't work, and you'll have a low, oil pressure light, indicator. So if that's the case, typically if that's the case and you're not hearing any racket coming out of the engine like you got low pressure like valve lifters or something, you can just screw another gauge in there right quick, or ground that wire and see if the gauge goes to the middle, screw another gauge in, put the light on, crank it up and see how it does. See what I mean? Too hard to do. It's fairly simple to knock that out. You can keep a good gauge that fits one of those in your toolbox. A good sending unit, and just try that. And a lot of these guys, fix stuff really fast because they get to where they're just, really familiar with the thing. Anytime you get working in a shop, you got to get a rhythm going. You got to get a rhythm going. When you get that rhythm going, that's when the money starts rolling in. But if you're scratching around and can't find your fanny with both hands, and you stand around at the water cooler and you waste time and you're there to socialize, you ain't never going to get nothing done. You're going to get paid nothing. They're going to let you go, and they're going to put somebody over there that produces. That service bay that belongs to that man that hired you, he expects that service bay to be cranking out a certain amount of labor hours every day. Because if it's not, that piece of real estate's costing him money to operate. He's got to pay to blow fans on it. He's got to pay to turn on the lights on there. He's got to pay all kinds. He's paying to run his air compressor. And also, when you get hired at a place, it costs $1,000 for them to put your boots on the ground. Because they got to set up your unemployment and your workman's comp and all that kind of hogwash. They have to pay money out of their pocket to put you to work. See? And my buddy Donnie, whenever he opened his shop, he said he didn't realize that until the first time he went to hire somebody and he got investigating what he had to do to put somebody on payroll. He said it's expensive just to put somebody to work. He shucked out $1,000 out of his pocket before he gives you your first paycheck, and it's money that's not going to get him, not going to make him nothing. See what I'm saying? No. So just remember that when you go to work somewhere, you're wasting that person's money if you don't do them a good job. Always make sure you do that. That's integrity, right? Okay, 16. Excuse me. A vehicle's electronic digital fuel gauge is always indicating a full tank. All the other gauges are operating correctly. See, that's a prerequisite. How do the other gauges operate? If it's something that's common to all the gauges, you go one direction. If it's something that's just on that one gauge, you focus on that. All of the other instrument gauges are, which of the following is most likely cause? So that would be high resistance in the fuel gauge center circuit is D. That's correct. Number 16. Technician A says a normally open switch is used in most coolant temperature warning lights. And that is pretty much true there, because most of them, whenever you ground that wire, anytime you're working on a gauge, if you want to see what the sound hill's going on, you ground the wire. Ground the wire and see what the gauge does. I usually like to do it with zero test light. It's not going to be a perfect ground, but it's going to be enough of a ground where it's going to cause that gauge to react. And that way, what do you know as soon as you ground that, as soon as you unplug that sender and you ground that gauge with your test light or whatever, and the gauge reacts, what do you know at that point?
That is still good.
The wire is good between the sending unit and the gauge. Then you look at the connector and you see if maybe the connectors are spread so they're not touching. Right. You're going to see if that. A lot of times you'll see that where somebody's crammed something down in there and spread them out. Now they don't work good, and you can jiggle the connector and a gauge would come and go. Yeah. That's more common than you believe. One of these Delco schools that this friend of mine went to, they said that when you take a General Motors wire connector, some of them, when you unplug that connector and plug it back together 4 times, you start having problems with it. Pin fit deteriorates every time you unplug the connector and plug it back in. It's on every car at some. You know, so the more you unplug a connector and plug it back in, the more trouble you're subject to have with that connector. And so that's why it's not a good idea to, you know, ignore those connectors, because a lot of the time. And did you know that on those Toyotas, like that car that we pulled all the wire harnesses and everything out of that 2000 Corolla, they do not have connectors that connect that. The harness on that thing is all one piece. I mean, they got connectors coming out of the panel. But on this Ford engine that we got out here on the stand, they got big block connectors. The engine is wired up, and then you got a big bulkhead connector. I mean, a big square connector that plugs into the harness that goes to the rest of the car, right? And then you got a wire harness here, and you got wire harness, and they all plug together. The wire harness is all plugged together, but every connector is a possible problem point. And so Toyota, in order to keep their wiring problems to a minimum, they don't have any connectors that aren't necessary, so the wire harness just goes through the firewall, through a grommet, and it goes on to wherever it's going. That's why we had 16 tons of wire over here. We didn't have anything we could unplug. You know what I mean? We had, so we're setting up that little dyno trainer thing over here. All right, let me see here. Technician A says normally open switch used in most coolant temper warning light circuits. Technician B says most oil pressure warning light circuit uses a normally closed switch. 16. That's actually C. That is, he's thinking the newest ones, you know, the older ones, the switch. If you've got a warning light, now, yeah, the normally closed switch, the switch is, well, if it's a light circuit, the switch is going to be closed when you don't have oil pressure. So if you just turn on the key and there's no oil pressure, the light's going to be on, crank it up, and when that opens up, the light goes off. But just about every car nowadays has got a light and a gauge. So it'll have a little wall light, you know, a double whammy. They want to make sure that you don't miss it. And they'll also have check gauges that comes on. Yeah. Which of the following is not true about a quartz analog speedometer system? Which one is it? Which of those statements is true? A, the signal from the PM generator is a DC frequency. What usually controls an oil pressure warning lamp? Number 18. It's going to be what? B? A ground switch. Technician A says, when testing a system using an IVR, use a voltmeter to test for the system. An instrument voltage regulator is what IVR is. Use a voltmeter to test for regulated voltage at a common point. Technician B says if regulated voltage is within specs, you must replace the printed circuit board. Yeah, well, that's A. But what I always do, you can tell if that instrument voltage regulator is working on those cars that have one, which the old bimetal kind. I don't know why they're doing this old. But if you touch your test light, it's good to use a high impedance one here. Touch your test light to the wire coming to the gate. Turn on the key, unplug the extending unit, touch your test light there, and you'll see that light blinking. Real faint blink. That way you know your instrument voltage regulator is sending a signal out there, right? Finally, number 20. On the other ones, incidentally, if you take a high impedance test light and hook it to a regular gauge, you know that where the wire is going all the way to the gauge, it'll come on kind of dim. That's what it'll do. Which of the following is, and the gauge will react, but which of the following is not contained in a 3-coil gauge? Number 20, that's going to be D. A non-reading coil. That's kind of dumb, isn't it? All right. All right, we got that one behind us. And let's move on to the next one.